to the Journey Shade Chem. Today is the real assessment. Well, please do the 2 warm-up questions to the best of your ability, and we'll discuss them in a moment. And number 1, we are determining if the compound is a weak, strong, or non-electrolyte. We're revisiting that penguin. And we know that the acids, there are 7 strong acids. If it's an acid and it's not one of those 7, it's a weak electrolyte. There are the strong bases are group 1A and 2A with hydroxide, except for beryllium. The salts are all strong electrolytes except for the mercury salts. That's a little bit of review before we do this problem. Well, in the first case here, I have a non-metal with oxygen. I have an acid anhydride, and all anhydrides are non-electrolytes because they're not acids, they're not bases, and they're not salts. And therefore, we categorize them as non-electrolytes. In the second case, we have glucose or fructose. They are isomers, and this is a non-electrolyte. It is not an acid, it is not a base, and it is not a salt. Therefore, it must be a non-electrolyte. Then we have hydrosulfuric acid. It begins with hydrogen, so it must be an acid. It's not one of my 7 strong acids, and therefore it is a weak electrolyte. And finally here, we have iron 2 hydroxide. And iron is not in the first column or second column. It's not an alkali metal or an alkaline earth metal, and it certainly is not beryllium, and therefore it is a weak base, it is a weak electrolyte. That's how you do number 1. Number 2 is a bit of review. We are either determining the pH or determining the concentration of the hydronium ion. We need these 3 equations. pH equals negative log of the hydronium ion concentration, which would be the same thing as the hydrogen ion concentration. The pOH is equal to the negative log of the hydroxide ion. And pH plus pOH is equal to 14. Well, in the first case, we are given the pH, and we know that 10 to the minus pH is what pH is. And on your calculator, you have a button that says log. And above that, it says 10 to the x. And that's what we need to get to when we are given the pH. We are going in reverse. And therefore, this is the same as 10 to the minus 6.56. Then I put the number in my calculator and make sure that it's negative and take the inverse log, and I get 2.75. Oh, I need 4 places. 42 times 10 to the minus 7th. And then we round these to the hundredths place. The 4 does not round the 5 up, and therefore we have 2.75 times 10 to the minus 7th molar hydronium ions. Now in the second case, we have a pOH. And because I need to get the hydronium ions, I'm going to go ahead and subtract it from 14 to get the pH. And the pH is equal to 9.75. Then I make it negative and take the inverse log. And I get 1.77, oh, I keep doing that, don't I? 1.7782 times 10 to the minus 10. Then I round it to the hundredths place. 1.78 times 10 to the minus 10 molar hydronium ions. Because the 8 rounded the 7 up. In the case of C, I am given a concentration of a hydroiodic acid solution. Well, I know that hydroiodic acid is a strong acid, and therefore we have 100% association. And we don't have to go through the equilibrium expression and whatnot to figure out what we would get for our dissociation. We know that it's 100%. And therefore, I just put it into my formula, take the log of it, and make it positive. And I get a pH equal to 7.6289. And I round it to the hundredths place. Therefore, the 8 rounds the 2 up, and I get 7.63 is my pH. In this final case here, we're given potassium hydroxide, and it's a strong base. Group 1A and 2A with hydroxide, except for beryllium, are the strong bases. And therefore, when I put this in my calculator and take the log, I'm going to get the POH. And it is also a strong base, so I know that it's 100% associated. And then the pH is equal to 3.5436. I'm going to go ahead and round it to the hundredths place and then subtract. And when I do that, I get 3.54 because the 3 does not round the 4 up. That is my POH. Then I must subtract it from 14, and I get the pH is equal to 10.46. We know that pHs and POHs are always positive values because that's why our sign in the front here is negative, because all of these exponents that we have are negative exponents, and when we take the log, we get a negative value. So our formula compensates for that to make a positive number. Our pH scale is from 0 to 14. Well, now you have an assessment, and I know you'll do well. You always do well. And just think, this is the last one, and you will have finished a complete year of chemistry. That's pretty exciting. And all you have to do now is the final exam, and we'll be reviewing for that for the next couple of days. Well, I wish you all the best, and I can't wait to see you tomorrow. Bye.